Hey class, how's it going? Today is Wednesday, April the 6th. We're still on Unit 7 of angles and triangles, but today we're going to go back and talk about angles a little bit more. We're going to look at angles of parallel lines. Just think of two parallel lines as they are two lines that if you brought them closer together, they would actually be the same line. It's like two lines on top of each other that have the same position, the same uh, the same slope, and then you just move them a little bit away from each other. They still have the same slope. So when you have a third line that crosses through them, the angles are going to be very similar to as if the angles that we had when it was just one line. So parallel lines, what are they? Does anybody remember what a parallel line is? A parallel line are two lines that never cross each other. They run side by side. They never cross, they never touch. Even if one line was just slightly tilted, eventually that line would cross the other line. So we're going to first review angle pairs because a lot of what we do with parallel lines is related to angle pairs. Do you remember doing angle pairs? If I have a line here and I have another line that crosses through it, we have different relationships for each angle. This one and that one, those are called vertical. And they're actually going to be the same degrees. They're across from each other. If we look at these two, that orange one and the pink one, they're adjacent because they share the same line. The orange one and the pink one are also called supplementary because the two angles together make a line. And then if I had a line like this, okay, and it made 90 degrees, then those would be called complementary, these two angles. The red angle and that pink angle there would be called complementary because the two add up to 90 degrees. So that was just a quick review. We're going to look at now what happens when we have a parallel line. So imagine I have two parallel lines here. Now that wasn't very good. Here, let me clear out everything. Imagine I have two parallel lines. So I have a line here, then I have a line right beside it. And even if we go down to infinity, down or up to infinity, these lines are never going to cross. They just keep going straight. Just like on a train or on a metro, if you look at lines that are next to each other, or if you look on your floor, I see some parallel lines right behind me here. You see these lines? This line and this line, they are parallel to each other. They're not tilted and angled, and if I was to extend that line, they would never cross. Or if you look on your floor, if you look at the lines of your tiles, those lines are never going to cross each other. The ones that are parallel. Okay, so there are parallel examples everywhere. So how are we going to use them? How are we going to use parallel lines? Okay. Well, normally we're going to look at angle relationships. Now, if they don't cross each other, then there are no angles, right? But we're going to look and see what happens when a third line or when a fourth or fifth line cross it. So we're just going to start off right now with that third line. So if I have a third line that crosses these two, now we have all kinds of angles. I have an angle here, here, there, 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 and there, and there. Okay, so we've already know some of these. If I look at this angle here and the one across from it, those are vertical. We know that they're going to be the same. But what if I compare some that are not touching? What if I compare this one, that light blue angle, with this light blue angle down here? How are they related? We're going to talk about that here in just a second. So we're going to talk about some of them when you have parallel lines and a line that crosses. Some of the angles are like the angle pair relationships we just had. Like, for example, these are vertical. And we also have complementary, and sometimes supplementary, depending on uh, how they are. So these two would be supplementary, and then if there was a 90 degrees, then that would be complementary. Okay, but then there's some angles that we haven't had before. One of them is called corresponding. Do you see how this is positioned on this line exactly the same as this one? If I was to make a photocopy of this line right here and move it down, then that would be this line right here. So this angle is in the exact same position as that angle. That's called corresponding. Corresponding means it's going to be in the same position on one of the parallel lines with the other parallel line, same position. So they're going to have the same value. Now, if I look at two angles that are the same on the same side, but they're in the interior, so let me pick another color. We have an example right there, but let me make it a little bit more clear. Like that dark blue and light blue are examples, but let's look on this side too. That orange and this orange are called same side interior. They're on the inside of the parallel lines, and they're on the same side. Those two add up to 180 degrees. And we can prove it, but I want to make this video short. That's something you could do on your own. So they have a sum of 180 degrees. Yeah. If you make some triangles, you can see really quickly. Then we have alternate interior. So alternate interior would be like this. If I have an angle on the inside here, that dark blue, and then this one over here is on the alternate side of that red line, but it's inside the parallel lines. The alternate interior. Well, guess what? These two are going to be the same. Again, if this orange one, or like light orange one, and that dark blue one together are supplementary angles, they add up to 180 degrees. Well, and that blue one, that dark blue one, and this orange one also add up to 180 degrees. So that makes these two equal to each other. Okay? And also, if we look at the same side, we look at alternating exteriors. So again, let me get some new colors because we have a lot going on here. Let's say I'm gonna make this one. I'm gonna change that to green. So we're gonna do alternating on this side, but exterior. So down here is also green. So if I look at this angle and that angle, they're on opposite sides of the red line, and they're both outside the parallel lines. These actually are also going to be the same value. These are actually kind of like vertical. Imagine if I squished those two parallel lines together, then they would be vertical pairs. So that's how you can find all the angles of when a parallel line pair have been intersected by another line. So let's go ahead and look at some examples here. So these two, that x and y, those are corresponding. That's in the same exact position as that one. What is this one? We have one there and one there. They're inside the parallel lines and they're alternating. So they're same side, they're alternating interior. That means these two are going to equal each other. And out here, we have alternating, they're on opposite sides of that divisive line, and on the outside of the parallel lines. So that's alternating exterior. These also are going to equal the same value. So if y, for example, is 120, then x would be 120. So all three of these so far, the y and the x are the same. Number 4, we already know this from before. Those are vertical, and we know those equal each other. Now look at number 5. Finally, we get to some one where they don't equal each other. They're interior, they're inside the parallel lines, and they're on the same side. If you see that, then you know you have to add them up to be 180 degrees. If I had a y here and an x there, they would also add up to 180 degrees. That's called supplementary. Okay, so let me just show you on Khan Academy what that looks like, and then we'll be done with the video. So we have 80 here, and we have x there. 80 and x, you want to say hi, no? Okay, so we have 80, which is on the outside of the parallel line, and x is on the outside, and they're alternating. So they're exterior alternating. That means they're going to be the same degree. Okay, good. Okay, looks like these are, okay, this is one we didn't talk about. We have same side exterior, okay? So if this angle over here is going to be the same as that one, right? Because this is alternating exterior, then x and 89 have to add up to what? 180. So these are going to be supplementary. So if they're the same side exterior or the same side interior, then it's going to be supplementary, which means we take 180 and we subtract the known angle. So that means x is 91. And then, oh, these are the same side, but they're alternating. One's outside and one's inside. This is called corresponding. So that means they're the same exact. So you get the point. So I hope you have a great day. If you have any questions, let me know. You guys are doing great. Bye.